Good morning, everybody. Welcome to the Friday morning West Coast time space show program, and I am your host this morning. Thank you very much for tuning in. We have a timely topic to talk about in just a few minutes. Some risk in low Earth orbit and what was scary about a recent Chinese human spaceflight mission. And I'll let our two guests talk about that, who I will introduce in just a minute. Just a couple of notes about what is upcoming. Tricia Epp is on Sunday, and she's the head of a NASA program called Moonshot Innovation, and that's our Sunday program. And Tuesday is by demand of listeners, because this group of people you see here, plus others, we constantly reference during shows that we're checking ChatGPT or Grok or this or that. And a lot of people are asking us how this group of people use AI, why they use it, what do they hope to gain from it, what kind of information do they get from it, how do they use it during live spatial programs. So I thought I would do a program and answer their questions. So that's on Tuesday. Um, no clue yet as to who will be with us on the Hotel Mars and John Batchelor. And then the Aerospace Corp team of Karen Jones and Rachel Simmons wrote a really interesting spaceport paper. And the space show certainly is interested and follows spaceport. So we will link to that paper, and that program has been moved to Thursday morning. So instead of a Friday show, it will be on Thursday, and I believe that's February 26th at 9:30. And then Sunday is March 1st, and the astronomer from the Bay Area, who we know and who's been on before, Andy Franknoy, is on because maybe you don't know, but we have a great total lunar eclipse coming up. It's at a god-awful time, I think, for the West Coast. I think it's like 3 o'clock in the morning. But he's going to talk about that and other astronomical events that are going on. And he's been doing an astronomy show in the Bay Area for longer than I was living in the Bay Area, which was about 55 or 60 years. So he's really a good guest to have on. So with us today is Marshall Martin right here and Phil Swan. Excuse me, this is Phil Swan, uh, John Hunt, and John Jossi. And we have two great guests for the first time with us. Um, Dr. Siamak Hesar, hope I'm getting that right, and Araz Feyzi, and their company is Kayhan, Kayhan Space. So they both have bios on the Space Show page. Let's talk to them rather than read about them, and you can find out more about them as we talk. So, guys, welcome to the Space Show. Thank you for being here. And when Hillary suggested the two of you to the space show, she suggested that you could address what this risk was in low Earth orbit, why this risk exists for the recent Chinese human spaceflight mission, Shenzhou 20. And I guess they were afraid of, or they had a scare regarding space debris damage. So, whoever wants to lead off, uh, tell us about what this is and how does this actually apply to the business that you guys have started with Kayhan Space.
Well, first of all, thank you for having us. It's a pleasure to be here. Nice to meet you, everyone. Yeah, so people, we are every aspect of our life these days rely on space, from navigation to communication. You pick up your phone, order food delivery. Most of that space touches different aspects of that certain activity, right? So we have gone from launching very few number of really big and expensive satellites 30, 40 years ago by governments to very small, very affordable and agile satellites that are launched by small startups. So we've gone from the beginning of from the dawn of the space age to about 10, 15 years ago, we had launched less than 2,000 satellites. Just in the last decade, we've launched, more than 10,000 satellites. So, and most of so, and the cost of by the cost of launch going down and the introduction of new technologies, now we are actually able to launch satellites to orbit at a much higher pace. Now, human activity in Earth orbit has resulted in creation of orbital debris. Now, uh, it's estimated that there are more than 1 million pieces of debris larger than 1 centimeter in diameter orbiting Earth. We can track everything uh, that is larger than about 10 centimeters in diameter, so about a softball size. So anything larger than that in low Earth orbit, closer to Earth, we can track that, which is about 15, 20,000 of them. So these pieces of debris are flying at orbital velocity. So think of it as like 17,000 kilometers per hour, really, really fast. So at those speeds, even a small fragment, if it strikes a satellite, it can destroy it. It can explode. The satellite will explode. It can create thousands of pieces of debris. And these pieces of debris, depending on where they are, they could stay in Earth orbit from a couple of years to forever, basically. And they, in return, will continue to pose threat to other satellites. So what happened in this particular incident was that I believe it was one of the docked stations to the Chinese space station. The window was struck by a small piece of debris, and so that resulted in a crack, and that kind of started this whole story. Because if you have a crack, and then it could disintegrate in reentry, and it could pose threat to the astronauts, and obviously other, it also could include other threats. So, for example, if the damage is extensive enough, it could rupture, and it could leak the air out of the station. So let me pause there, see if you have any questions so far, and we can get started from there and talk more about it.
Well, I have two basic questions for you. So, one is if you got a taikonaut or an astronaut doing a spacewalk in Leo and got hit by one of these tiny little things, I'm assuming it would wreak havoc with his spacesuit or her spacesuit. But has anything like that ever happened? Can they tell if they're at risk for that on a spacewalk? And the other thing is, I don't know what the pressure is of a Chinese space station, but I think NASA pressurizes to a little bit different than 14.7, but not much different. So the inside is pressurized. There's no pressure outside, and you got this crack in the windshield. Why the hell doesn't it blow up?
I can answer that. Yeah, thanks for having us. Um, to answer your first question in terms of spacesuit, yes, that is totally a possibility. In fact, a couple of years ago, I forget exact date, the Canada arm on the ISS was struck by a piece of debris, and the insulation was damaged. So if your audience, if you don't know what Canada arm is, it's that robotic arm that extends from the ISS, and they are able to do some repairs, or like docking of the Dragon, the last step of the docking, they grab it. So or other pieces. So and also astronauts attached to it, sometime doing repairs and outside of the International Space Station. One lucky, I guess, coincidence here, which is math, but I guess I will put it as a lucky coincidence that obviously the surface area of a human being is very small relative to everything that's happening. So it reduces the probability of collision with an object, right? So hopefully that will give some solace to people that might be concerned. But also, yes, I mean, International Space Station, there's a whole team of analysts at Johnson Space Center that their job is to track objects, and make sure that any objects that come within 200 kilometer of the ISS is basically alert, raise a flag, and they keep track of it. If it deemed that it is going to cause an concern for the ISS actually performs an evasive maneuver, or collision avoidance maneuver, we call it. In fact, in the Araz mentioned this increase in the number of activity that we have had in orbit in the last decade. There was another report that came out last year. The number of collision avoidance maneuvers that ISS has performed in last couple of years has been more than all the collision avoidance maneuvers that it had to perform over since its existence.
But
So obviously, yeah, go
well, they
ahead.
can't track the little tiny specks, so they're just at risk for that.
Yeah, go ahead, Araz, if you want to answer.
Yeah, so there, that's true. We cannot track them yet, and so there's a certain size that above which it can actually be lethal. So there's that risk. As humanity, our goal should be not to increase the number of debris that exists in low Earth orbit. But yeah, there are objects that we just literally cannot track, and they can, if they strike a satellite, they can destroy it. If they strike an astronaut doing a spacewalk, it can cause harm. Um, the good thing about very low Earth orbit is that there's a little bit of atmosphere there, still very thin. So there's that drag that slowly slows everything down, and then they kind of gradually deorbit. But when you go higher up, so let's say more than 650 kilometers, 700 kilometers, where the atmosphere is much thinner, then if you have an object that's in that altitude, it will stay there for a very, very long time. So again, if you have objects up there that are coming down, or their orbit, there's always orbital debris in low Earth orbit. But again, low Earth orbit, the lifetime of pieces of debris in very low Earth orbit is relatively low. But yes, there are non-trackable lethal objects that exist up there.
What about my second question? Why doesn't the internal pressure of the
Mhm.
capsule blow the window out if it's cracked and weakened?
I can answer that. So in fact, yeah, the inside of the spacecraft that are human, like crew rated spacecraft, are pressurized, but they are actually pressurized. Don't hold me to this number, but it is yeah, it is a lot less than what we experience here on the surface of the Earth. And there are a couple of reasons for that. Obviously, because it's a little bit oxygen rich, the environment inside the International Space Station or others, and we have had in the Apollo times, we have had incidents that oxygen has led to basically explosion or burning of the unfortunately astronauts during the ground test. The atmosphere pressure is low, but it's oxygen rich, also to reduce the nitrogen in the inside the bloodstream of the astronauts. So all that put in aside, there is still a positive pressure compared to the vacuum of space, which is not a vacuum. There we still have molecular atmosphere there, but for all intents and purposes, it is vacuum. However, these glasses that are basically crew spacecraft rated, they are pretty thick. They go through rigorous testing. In fact, there is a company that their specialty is to build glasses for spacecraft that are going to take humans to space. So they go through rigorous pressure testing as well as thermal variation testing to make sure that by hitting an object, it's not going to just blow a hole in the spacecraft.
Okay. So unless somebody else wants to step in, go ahead and continue before I interrupted you.
No, I think that yeah, that's
So their window broke, their in the capsule broke, and how did that modify their, I'm going to use the word behavior, but I
Mhm.
don't individual behavior. I mean, it modified what they did with the capsule. How, why did they have to make modifications if the glass is so thick it probably wasn't going to depressurize explosively?
So what happened was the object that struck it, it was small, so it created a 2 centimeter long crack on one of the pieces of glass. And I don't, I mean, after the analysis that they did, they decided that it's not really safe for the Titanos to return in the same capsule. So luckily, there was another capsule that had just arrived uh, earlier. So they actually used the other vehicle to return to Earth. So I think the number 20s was the one that was struck,
Uh-huh.
and then the number 21 had just arrived, and then they used number 21 to return to Earth. And what happened before doing that, they actually performed a spacewalk to go from outside and patch the crack from outside. And the damaged vehicle returned without astronauts in them successfully back down to Earth. So at the end of the day, it ended up being safe to return, probably due to the repair that they did. But at that point, it was very risky to continue to stay there with that cracked vehicle attached, and it was not deemed safe to be used with Taikonauts to return to Earth. So they used another vehicle that was there to return.
It would be really just desserts if the piece of debris that hit them was created by their ASAT test several years ago. Any idea what debris or its origins hit them? Can it be identified to saying this is a result of their ASAT test?
I don't think so. The reason is that it was small enough that it was not tracked. Because if anyone can track any of those pieces of debris, they will, so whether it's Americans or Russians or Chinese or whoever, they will let the operator know. So in this case, they would have let the Chinese Space Agency know that there is a piece of debris that they're tracking that is going to get close to space to the station. So the fact that nobody knew that it was going to happen, and it was discovered after the fact, that tells me that that's a non-trackable piece of debris. So if you can't track it, we can't really reliably say what the source of the debris was.
So we're in the 25th year of the space show, and almost from the start, we've been talking about the LEO space debris problem. And there's this company will arrive that says they have a solution. This one says they're working on a vacuum cleaner to clean it out. I mean, we've heard it all, and zero exist. And you've probably heard it all too. Why is this such a difficult problem that somebody out there, entrepreneurial or government or something, can't develop a method to mitigate this problem?
Araz and the team have heard me say all the time that space is hard, and it is really hard. But that doesn't mean that things are not happening. Um, you know, um, Araz mentioned in terms of the rate at which we have grown the activity in space, like especially in LEO. And that has just been in the past decade, right? It is very recent. Starlink, the first Starlink was launched in 2019, if I'm not mistaken. So this is a very recent problem. And there are a lot of companies that are uh, in the business of trying to solve this growth of risk in space. We are one of them. Our role is to ensure coordination between satellite operators so they don't run into each other inadvertently. But there are companies, we are Colorado-based company. There are other, like there's another company, Astroscale, that is located here in Colorado, and also their goal is to clean up the space debris. But this is a large problem that has the scale of it has been very recent, and there is definitely momentum, but it's going to take time for us to have an equilibrium, so to speak, when it comes to this issue. Araz, do you want to add anything?
I do. So when we talk about the space orbital debris, there are non-trackable lethal, the non-trackable very small ones that, if you talk to astronauts, they'll tell you that they hear these dings that something hits. Maybe it's a micrometeor or it's a orbital debris that hits the station, creates a noise but doesn't penetrate, right? But they're having cases that they can penetrate and go through, and there are objects that they're big enough that it can actually cause real damage. And then you have these like giant pieces of debris that we've left up there long time ago. So these are, for example, rocket bodies or really big satellites that we have launched, and they have reached end of life, so we can't control them. Now, in my opinion, the biggest effort should go toward not creating new debris. And one of the biggest threats right now is these really big, really massive, thousands of pound kind of pieces of junk that have been there for 20, 30, 40, 50 years. And then if they collide with each other, that is going to be a really, really big problem, because they could generate tens of thousands of smaller pieces of debris that can threaten everybody else, right? So first of all, starts by us not creating new debris, meaning don't try to blow up anything intentionally. Um, uh, Very actively deorbit second stages and satellites after they have reached end of life. So those are kind of like two very basic steps. But if you want to take steps towards reducing the orbital debris, in my opinion, the biggest bang for the buck comes from taking care of these big pieces of junk that are flying out there and they're not controllable. Because if you have a satellite that's operational, that's going to get too close to another piece of object, they can perform a maneuver and get out of the way, right? So that's what Starlink does all the time. That's what other satellites do all the time. And there's a high risk conjunction event or close approach, they maneuver out of the way. But when you have two giant pieces of second stages that are not controllable and they have decayed over the years, if they hit each other, we can't do anything about it, right? Like if you realize that 3 days from now there's a high chance that two of them are going to collide, there's nothing we can do about it. And it could happen today, it could happen tomorrow. We've been lucky so far it hasn't happened. But one of the biggest things we can do is to take care of those. So how can we take care of those? Well, there are companies that have created, that have developed, and they continue to develop technology where they can go fly their satellite, perform rendezvous and proximity operation, get close to these pieces of object, and this hasn't been demonstrated completely by a commercial company yet, but theoretically they can grab these pieces of objects or attach to them, and slow them down or perform maneuvers to change their orbit in a way that they will re-enter atmosphere and burn up in the atmosphere, not to continue to pose threat, right? So that's a really good step toward reducing orbital debris and also reducing the risk of generating more debris in space.
I want to add something to what Aras said, and to answer your question, completely agree with what is just said. I personally think the technology is there, that we have the technical solution to be able to go, as Aras said, get close to these objects, large objects, and de-spin them. A lot of times they are spinning or tumbling. We need to de-spin them and then detumble them and then be able to grab them. When it comes to space, obviously space historically has been also a very, a national security heavy domain, right? So as a result, we haven't had a lot of, and because this is a very nascent problem, we haven't had the regulations catch up with the technology. We do have the technology, but guess what? If you have the capability that you can go and grab a rocket body and deorbit it, you can also have the same technology to go and grab some other country's satellite and deorbit and render it inoperable, right? So that is a big concern. And there is a lot of conversation, with the US government, with other governments, that how can we basically figure out this legal framework that it allows commercial companies to go and actually do this. I would say one of the big, the speed bumps here has been the legal framework and regulation that are not able to catch up with the technology and the growing problem.
Marshall, you wanted to jump in?
Yes. Um, about, what was it, 4 months ago, we had Abby Loeb on the space show. And of course, he was talking about interstellar objects zooming through. And then we cross that with the topic you're talking about right now, and that is how much effect does all the asteroids and comets could possibly have on junk space objects and um, the the explosive um, uh, huge numbers of objects uh, spreading out and so on, which would imply that, hey, we better get up there and get rid of this junk as soon as possible so the interstellar objects zoom by instead of going kasplat. Is that good enough?
Maybe that would be actually a good scenario, so we can get some pieces of the interstellar object falling on Earth
Ooh.
to figure out what it is. But um, so yeah, actually, there has been studies that is done that obviously when we have in the work that we do, we track objects and we predict where they are going to be. We have to be taking into account the gravitational forces of the sun, the moon, even Jupiter sometimes. Asteroids are not really large enough to impart really any appreciable amount of gravitational force in that distance. But when we are doing precise what's called orbit determination or prediction, we have to take into account even gravitational perturbation from Jupiter because it's a very large object. So definitely those gravitational perturbations, they impart what's called a secular effect on the orbit of these objects, on the orbits of objects around the Earth. And depending on what altitude is, obviously that the intensity of the gravitational perturbation can be low or high. But what the resulting effect of that is that sometimes that perturbation ends up being in synchrony with the rotation of the moon around the Earth and the rotation of the Earth around the sun. And that synchronous effect ends up putting these objects in what's called very stable orbital regimes that they can stay up there for hundreds of years. Um, so there's definitely that effect that is happening. But also you brought up another thing. I when I was doing my PhD, I worked on the OSIRIS-REx Aster sample return mission. It's a fantastic mission. Obviously, NASA is very active on interplanetary mission. We have a big interest in going back to the moon and the Mars. Anytime that we need to get out of the Earth's orbital environment to go visit other celestial bodies, we have to pass through this cloud of debris, right? And that is why I 100% agree with what Araz is saying. Number one thing that everyone in this industry should be concerned about is not to create additional debris.
Do you think they are concerned about that as number one?
We have seen, yes. So I am very pleased to kind of see that in the last few years, we have started seeing a lot more awareness from satellite operators when it comes to spaceflight safety. I'll give you a very a concrete example. As a company, we always get proposals about requests for proposal, RFPs, for people that do BD work, about the mission requirements and about our services, and they ask us to put proposals in. We used to get proposals about missions, and spaceflight safety was not even mentioned, or was just single line in those requirements. Lately, every proposal that we receive, this idea of conjunction assessment, collision avoidance, spaceflight safety is basically has its own section. So this is very encouraging for us to see that satellite operators, even before they launch, even before they even build a spacecraft, they are thinking about this. So that is definitely encouraging. We just need to keep pushing in the right direction.
A couple of
One thing I would want to mention here, interesting, is it depends a lot on the orbits that a particular piece of debris would have on the destructive effect. I mean, if we're all going in a, kind of a eastward direction in a certain orbit, I would think that the relative velocity would be much. But if something comes in from a polar orbit into an equatorial type orbit, or something elevated up a little bit, that's going to be a much more dramatic collision, let alone something that's going counter around the Earth the other way. That would be dramatically different.
Totally. In fact, one of the biggest collision events that in the history that has happened, it is Cosmos and Iridium satellite that they collided. It was a defunct Cosmos spacecraft, Russian spacecraft. They collided over the South Pole. Memory serves me well, and that was especially destructive because the collision was almost 90 degrees. Their orbital planes were 90-degree apart, so the impact force and the delta V. I mean, think about it for your audience. Araz mentioned this point in the earlier orbital velocity in lower Earth orbit is 17,500 miles an hour, right? So that's 20 times the speed of a bullet. Now, if you have two spacecraft that is 90 degrees to each other, hitting each other, that is multiply that by the square root of 2. So that is a significant amount of momentum that can create a lot of debris.
A couple of months ago, Kessler, I think his first name is Don, but don't hold me to that,
Yes.
published an update to his Kessler theory that we're headed for doomsday in the AIAA monthly magazine. And he said his theory is certainly still very much alive, and we have borrowed time. Uh, do you concur that we have borrowed time until something like the Kessler effect were to really materialize, or is that still pretty elusive?
Um, there's some. So most of the, again, going back to what I said earlier, most of the growth in low Earth orbit has been in low Earth orbit under like 550 kilometers or so. And that's where most operators are going to. And again, one of the nice things about that environment is that there's still a little bit of drag. So the pieces of debris won't last forever, right? That's this one positive thing. There's a belief that Kessler syndrome is happening in smaller scale in certain areas, right? So you have these small pieces of debris that hit each other and create more smaller debris, but these are non-trackable. But the Kessler syndrome is a really scary thing, and we should really be worried about that, because just think about it. If low Earth orbit becomes unusable, then you pretty much won't be able to launch anything through it, right? So then there's no going to moon, there's no going to Mars, there's no going to geostationary orbits. We'll actually lose that. We could potentially lose access to space if the Kessler syndrome actually happens and happens at a large scale. So it is a really scary possibility. But again, going back to what Siamak was saying, we do see really good behavior from a lot of operators. for example, if you look at Starlink, and maybe Siamak will have the right number for me, but I think their risk threshold to move out of the way of piece of another object, I think it's one in 1 million. Siamak, did I get that right?
One
Or one
in
in 100,000.
100,000.
Okay,
Yeah.
1 in 100,000. So if there's a 1 in 100,000 chance that they're going to hit the object, then they will perform a maneuver to reduce that risk even more, right? So they are being very, really careful not to generate more debris. Or every time one of their satellites reaches end of life, they reserve enough fuel to actively lower the satellite for it to burn up in the atmosphere. And not only that, they have a capability that they use their solar panel to change the drag, like a rudder, to actually point the satellite as it's re-entering to be more likely to fall in the ocean and not hit Earth surface to cause damage, right? So a lot of operators that understand the situation, they actually are doing everything to prevent creating new debris. But again, we see some not so great behavior, right? Not pointing fingers, but there have been recent launches in the last 2 3 years that second stages have been left up in space, right, or Earth orbit, or launching launch vehicles that have blown up recently, and then we continuing launching the same launch vehicle, you know is not responsible. So there is still some irresponsible behavior, but luckily we haven't seen any ASAT recently, and we are seeing more and more regulations, light touch regulations around the world that being proposed and being imposed for satellite operators to be more responsible. But again, cancer syndrome is really scary. It is a possibility. It could happen, and we should do everything we can to prevent it from happening.
I want to add something else about that, and I have spoken to Kessler myself. I have a lot of reverence for him. But there's a little bit of nuance, and yeah, absolutely. It's a risk. It is a risk that we need to take it very, very seriously. But we need to dig a little bit deeper into the numbers. And in the work that we do, we have been doing this for a long time. I've been doing this for a long time. A decade ago, or even 5 years ago, as recent as 5 years ago, the largest number of conjunctions, which is like these are potential collisions between two objects, used to be between two pieces of debris or a piece of debris and an operational satellite. Today, it's almost 50-50. The number of conjunctions between two operational satellites is almost the same as the number of conjunctions between pieces of debris, because suddenly we have a lot more operational satellites that are maneuverable, which is a key here, because obviously debris cannot maneuver, right? Two debris that are in conjunction with each other, they cannot change course, as Araz mentioned earlier. So although the number of objects and the congestion is increasing, which is a parameter in Kessler's model, but they are maneuverable assets. And going back to Starlink example, Starlink is performing in one quarter of the year. Last quarter, I believe they performed 140,000 maneuvers to evade objects, right? So they're literally, my best analogy is that you are driving down a very cluttered highway, and you keep basically moving like this, and that is literally what they are doing. So as a result, we have active satellites, even though the numbers are high. We are actively, or the operators are actively avoiding conjunctions. So that is something good that is going towards making sure this, not making sure, but hopefully for the Kessler syndrome not to happen at scale. But it is a risk, and we need to not lift the foot off the gas when it comes to making sure that we are ensuring spaceflight safety.
Do the competitor to Starlink pay attention to it like Starlink is as well? And are the constellations that we keep hearing, this one's going to have 20,000, this one's going to have 5,000, are the constellations a problem or are they dealing with the problem so that they are not contributing to the problem?
Yes, most large operators are doing everything they can to be responsible. Actually, a number of them have gotten together and they have released their recommended best behavior in space and talks about all of the right things, right? So, deorbit your satellite controllably, coordinate with others what you're doing, and all of that. And I believe they're working on an updated one. So yes, all the competitors are also doing the right things. I want to actually take this opportunity to talk about another problem that we have at hand, and that is coordination. So when you have a piece of an operating satellite and an operational satellite that can maneuver, and let's say a piece of debris that they have a close approach, the satellite can move out of the way and reduce the risk of conjunction or collision, right? When you have two operational, and so when the satellite is designing the maneuver to get out of the way, knows that the piece of debris is not going to change course, right? So it's relatively well tracked, hopefully, and then we know that it's not going to change its trajectory. So very confidently or somewhat confidently, the satellite operator can design a maneuver that knows is actually going to reduce the risk of collision. When you have two operational satellites that both are maneuverable, it becomes extremely important that both operators coordinate with each other to make sure that they don't perform maneuvers that combined increase the risk of collision and reducing it. So if I imagine two satellites, one from US, one from another country has a close approach, both of them without talking to each other say, you know what, I'm going to raise my orbit to avoid the other one. To both do the same thing, and instead of reducing the risk of collision, they actually increase the risk of collision. And that's a problem, unfortunately. Unfortunately, there are operators that just simply do not coordinate. And mostly Chinese satellites, Chinese constellations do not respond to Western operators when you have this case. There are several cases. I mean, if you look up on the internet, there's several cases in recent months where there was a case where a North Korean satellite had a conjunction with a European satellite. There was a case where Chinese space station had a conjunction with another Western satellite. There's always this problem of, okay, how can we do that? We really need to solve that problem because that is another massive step toward reducing the risk of creating and introducing new piece of debris.
Bill?
I had a question about the satellites are trackable, but the stuff that's below 10 centimeters, and they've been saying 10 centimeters for so many years now. I don't know how many years this goes back, but I'm wondering kind of as you get smaller and smaller, if these particles will naturally deorbit and therefore not really a concern, or if they're just not trackable, and if there's anything that anybody's doing to do a better job of tracking them, like making better radars or putting detecting satellites in orbit so that they can actually see these smaller objects and at least get a sense of how many there are. Can you tell us a bit more about what the smaller object situation is?
Yeah, absolutely. So a recent advancement in the space surveillance networks arsenal, your audience can go look it up. The Space Surveillance Network is the largest space tracking, basically infrastructure, radars on the ground, optical sensors, both underground in space. They are tracking space objects. A recent advancement to that system has been what's called space fence. This basically what it is, it's a higher power level radar that is able to take that 10 centimeter that you're talking about to around now 3 centimeter. So the challenge, however, is that the space fence is just, one radar, and then it is hard. And that is basically the type of work that we do that, when you able to see an object just once in their orbit, it is very hard to build a good orbit to be able to accurately predict it. But that radar obviously is able to see smaller objects. Now, when it comes to the behavior of small objects, there is a lot of research around this. Obviously, not all the objects are created equal. We can have a piece of paint chip that literally comes off the rocket body versus a piece of bolt, right? or something that is dense. So the objects that are dense, they are actually, even though they sound scary, they are actually better to deal with because they are very predictable in their orbit. They don't get affected too much by atmospheric drag. However, the objects that are low density, like piece of paint chip, those are, or a piece of solar panel, right? Those are very difficult, and we have a terminology, we call them hammer object, high area to mass ratio. And they are the ones that are very difficult to track because they get affected by the atmospheric drag quite much. So it is very difficult that when you see an object here, in the next rev, you're going to see it again in the same place because they get drifted in a way, right? Similar to having I don't know, a piece of feather in the wind. I mean, it's a very extreme example, but analogy, but that's what's happening. And obviously, when it comes to very small objects, NASA has done quite a bit of research. In fact, the pieces that have come back from, the Hubble Space Telescope after its repair, and a couple of other analysis that they have done in terms of the impingement of these smaller objects on the surface. There is and also the models that they have, not, the data sources, not just that, there are other sources. There's a program called ORDM, Orbit Debris Model, that kind of predicts the density flux of these very small objects in orbit. Again, those are very models that they can be accurate, inaccurate, but at least that gives us an idea of what is out there.
Marshall?
Yeah. I read a couple of weeks ago, I think maybe it was just a week ago, about a Russian satellite in geostationary orbit that disassembled itself, which brings up the obvious question of what do you do with old space satellites that are in geostationary orbit and there's nothing up there to drag them down? Where do you put them and how do you get rid of them?
Again, very good point and a good question. I'll answer your last question first. When it comes to geostationary satellites, the idea of end of life, disposal is as important as LEO objects. Obviously, for LEO objects, you can deorbit. For GEO objects, what happens is that you raise their orbit, right? And you put them in what's called, super geo or high geo. So that puts it outside the way of the geostationary satellites. However, that doesn't bring the risk to zero because over time, those objects, their orbital shape from circular starts becoming more egg shape, right? More eccentric, and they can come and intersect with the geostationary satellite. So there's still risk there. But that's the standard way of dealing with end of life geostationary satellites, to raise their orbit and put them in the graveyard orbit, what's called. Now, when it comes to the event that you're mentioning, and this also happened with the Intelsat satellite, the residual, and what Araz pointed out in terms of making sure that we are improving our designs so that we don't create more debris. There are a lot of defunct satellites that they have residual, either unpassivated batteries or not completely emptied fuel tanks. And over time, because of whatever, a lot of dynamics that are happening, though the fuel tank, but also the battery can explode. And that happened in the case of Intelsat 2 years ago. Was it 2 years ago? Time passes by very fast. That basically the satellite itself, nothing hit it, but it just exploded. And that's because there was some leftover energy in there that was not passivated. And over time, there's a lot of stresses, environmental stresses over on a spacecraft in orbit, and then that causes that thing to blow up, and it resulted in a few hundred pieces of debris that we can track right now.
So what about tracking the debris at that distance? Do we have the radar systems to do it?
So telescopes are mostly used for tracking objects in geostationary orbit. So we have telescopes on Earth that they look at all around the Earth, different stations, right? And then they look at these objects. They collect observations, and those observations are used to create tracks for these objects. For active satellites in geostationary orbit, there's also a technique called passive RF, radio frequency. So if the satellite is operational, if it's communicating, if it's broadcasting, you can use that to also calculate the orbit for them. But for debris and non-operational satellites, we generally rely on telescopes today.
So we have to address the recent announcement from SpaceX on their Stargaze system, which came out late last month. I don't know if you guys have heard of this, but they have a space situational awareness system. I put a link in the chat that delivers several order of magnitude increase in detection capability compared to conventional ground-based systems. And Stargaze uses data collected from nearly 30,000 star trackers, each of which makes continuous observations of nearby objects, resulting in approximately 30 million transits detected daily across the fleet. So that should definitely help with situational awareness in orbit.
Yeah, absolutely. Go ahead.
Go ahead. No, go ahead, Araz.
Yeah, we are very short answers. We're very excited about this announcement and its capability. Actually, we have been engaged in a different contract, a government contract that kind of have been in development for a couple of years to get to this point, which we can't really talk about much publicly. But the idea came to mind that, okay, so we have these star trackers on these satellites. So the job of a star tracker is to look at the dark sky, identify satellites and planets, and based on that, to figure out what the attitude of the satellite is, right? It looks back and says, okay, I think this is my attitude. It's used for attitude control. But then what happened was, obviously, you can see streaks of objects passing through the images, and the idea was that, okay, so can we take these streaks and actually do space situational awareness with that? So now fast forward to today, that has proven that it's possible, and it's actually very effective. So right now, I don't know the exact number, but I think Stargaze can track 60 to 70% of the objects that radars can track reliably. So radars are still doing a better job of tracking smaller objects, because depending on the geometry of it and the size of the object and the lighting and the quality of the star tracker, there's certain limitations today, the way these star trackers are done, and how small, basically seeing small objects is harder. But obviously, the technology we advanced, we're going to have better sensors and all that, and that gap will close, and there's actually an opportunity that maybe star trackers will do a better job than radars in the near future. But one of the great things about star trackers is that there's a lot of them in space, right? So you have all these Starlink satellites. They have several star trackers. You have all these other satellites from other constellations are flying. Most of them have star trackers. So you can keep an eye on an object. I don't know, can share the number, but more than 50% of the time in orbit, right? So a satellite is flying, and then with the number of star trackers that we have, the Stargaze can keep an eye on those objects more than half of the time. But with other sensors like radar, it's not the same, because you might have a radar here and radar here, so object passes over this radar, you don't see it for hours, and then it will, or minutes, or may cross another radar, and then you can kind of take the data from those radar stations, and then create an orbit. But with Star Tracker, you can actually see object as it moves from one view of one satellite or one Star Tracker to another. So that allows, so now we can do a lot more with that type of tracking than we could do with the past. So if a satellite starts maneuvering, sometimes you actually can see that as they are maneuvering. You can actually see the change of trajectory as they're maneuvering. So that becomes really interesting, right? The reason Starlink does this is because they have this data. They can see all these objects. And first of all, then they can use this data to keep their constellation safe. So today they rely on government data that comes from Space Surveillance Network or Space Force or US Space Command. They rely on some commercial companies that use their sensors to track objects. But now they can actually use their own sensors to also make sure that they keep an eye on all these other objects that are flying around them. And they had this capability and said, you know what, why don't we share this with others so they can also use this to stay safe. So we have, as a company, Kayhan Space, we have a service called satcat.com. I'll put it in chat, but it stands for satellite catalog. So satcat.com. Actually, if you're not a satellite operator, you can still go and use it. You can look up satellites. You can look at the history of them. You can look at their orbital changes. You can look at space weather. There's a lot of free information there that can be used by anyone. And our platform, SatCat platform, is already integrated with Stargaze system. So our customers, our satellite operators, when they come to SatCat, not only they get spaceflight safety data from government systems that we have integrated with, but they also get data from Stargaze system as well. So I'll add one more thing and I'll stop. So the way it works, to simply kind of explain how it works, is that let's say your satellite is flying, and then you have GPS. Most satellites have GPS on board now. So you use the onboard GPS on your satellite to calculate your precise trajectory. Now, you know where you are, and now you want to perform a maneuver. Let's say you want to do an orbit maintenance maneuver, or you want to raise your orbit for whatever reason. So you design this maneuver. It is very important that before you actually perform that maneuver, to simulate it, to make sure that by you moving, you're not actually putting yourself and somebody else at risk. So imagine two drivers and coming, one moves in front of the other one without using blinkers. That can cause trouble, right? It's just the same in space, because ground trackers can only see where you are based on where you were. So it assumes that you're not going to move. So if you actually perform a maneuver, no one will realize you performed a maneuver hours or maybe days later until they collect more data on your new trajectory and realize you move. So it's very important for operators to share their maneuver plans with others, for others to know this is happening. So let's go back to this example. I know where I am and I want to raise my orbit. I have a maneuver that I have in mind. It's a candidate maneuver. So we encourage everybody to submit that to SatCat as an operator. So what we do is that we take that and we run it against certain what's called screening. We screen that maneuver against several databases. The first one is the catalog of space objects that include all the debris and operational satellites that US government collects. So we say, okay, we ran it against this one. And if you actually perform this maneuver, you might have a high-risk conjunction event with this piece of debris. So they know and they won't do it. So that's one database. The other database is that we collect close to 11,000 what's called ephemerides from satellite operators. So these are GPS-based trajectories of satellites that satellite operators themselves have calculated. So we bring that in every day. So we have fresh trajectory, and that's very precise. That's more precise than tracking data because that's generated with the GPS data, right? And then on top of that, the operator can also opt in to use Stargaze to also screen it against Stargaze. So we submit it to Stargaze, and then we get all the data back, and then we combine them and we show it to our operator. So as an operator, you submit your maneuver, and you get a report back and says, hey, if you do this, you're based on these 3-4 systems that we've used, there's a high risk that you're going to get too close to the satellite, or you might get too close to this piece of debris. So then operator can select another candidate maneuver to try that. So this makes space a lot safer. And not every operator does it. So we try to spread the word, and we do a lot of advocacy that satellite operators should screen their maneuvers before they actually perform them. That just makes it safer for everyone.
Can they do the reverse? If they want to, if they know where they want to go, can they ask you to um, look at your database and then provide a maneuver?
So they do it internally themselves. So they do it against the same three data sets that I mentioned. They screen against their own database, they screen against just government database, and they screen against, yeah, so those two. But majority of the, but yeah, they do perform perform screening.
No, I'm asking, can you provide a customer with a maneuver rather than them submit the maneuver to you? They just say, I want to end up here. Um, can you provide that information for them? I guess that's what you're
That
doing.
that was our very first service when we started the company. That's
Okay, great.
exactly what we provided because traditionally designing a maneuver has been very just like anything that was done in old space regime versus new space was very manual, very cumbersome, very time consuming, and that was our first, so to speak, value proposition to the industry when we started the company, that we can actually increase the efficiency of this conjunction assessment and collision avoidance timeline, but more than 99% because we can automate that entire process. So yes, we do automate and we provide automated collision avoidance instructions to our customers.
What are what is the complete line of product and services that your company provides? Are you hardware oriented, software oriented, both? Are you looking to sell to private sector, to the government, to all governments? Tell us a little bit about what you guys are doing in this field, or if you're involved in other fields, that too.
Yeah, absolutely. Thanks for the opportunity to advertise the company, our services. So, yeah, as Araz mentioned, satcat.com, that is our main platform. I put the name on the chat, the link. So I encourage everyone to go look at it. You don't have to have a satellite in space to be able to use it and get a lot of good information out of it. But to answer your question, let me take a step back. At the core of it, Kayhan Space is a data aggregation company. We happen to obviously, we are very much focused in the space application, but we are a data aggregation company, and as a result, we collect data, as Araz mentioned, some of the examples from many different sources. Our focus is providing space flight safety to commercial and government satellites. So that is one focus of the company. So we satcat.com, it has the paid services obviously behind the paywall, and we provide a full suite of capabilities. Before you even launch your satellite, you can work with us to design your satellite for safety of flight. With safety of flight in mind, we can do the analysis for you. Right after you launch, there's a significant problem today, is that, which is a very recent problem with all the ride shares that are happening. One rocket can deploy up to 100 or even more satellites. So being able to figure out which satellite belongs to yours, that can sometimes take a while. So we provide that service as well. So all the way from design, before you launch, right after launch, we identify your satellite very quickly. We help, we also, have, work with the government to be able to catalog those objects faster. And then after that, we provide on-orbit services as well as at the end of the life, deorbit services. So basically tracking your satellite, making sure where you are going, and keeping it safe. So that is the full line. We also we have algorithms that are that can run on orbit on board the spacecraft. We have programs that we are working on those. And because we have amassed a large volume of data, historical data as well as current data, real-time data from all space objects, and also all the companies that work in the space industry, we are providing also a lot of analytics capabilities. This can be for financial industry, for insurance purposes, for many other, for investors, about a history of a company, about the many different aspects of a orbital environment.
Do you have competition?
When it comes to this data aggregation platform and how we are working, we are there are companies in Europe and in the US that are doing similar work, but majority of them, they have their own sensors, and they use their own sensors to collect data and basically do this similar work. Our advantage is that because we are sensor agnostic, we can work with all these different sensor providers. So in that sense, in that niche area, we are the largest platform. In fact, we are, I guess, going to announce, but more than 50 satellite operators are using our platform today. And we are by far the largest platform largest commercial space traffic coordination platform.
Are you private or thinking about going public? And do you get your
Uh,
funding from venture capital, or are you operationally profitable?
We are venture backed. Our model is to grow fast, so that's the model.
So you may go public later on then, I take it.
I mean, the company is just 7 years old, so thinking about that's still far out field for us. And right now we are focused on execution.
Are you positive with revenue from operations now, or are you still looking for venture funding?
Yeah, we're growing really rapidly. As you can imagine, this is an industry that's advancing really rapidly. So we have to heavily invest in R&D. And as because of that, we are still raising venture capital because, again, a lot of R&D needs to happen for us to be able to lead the industry in this area.
Are you hiring, and what's the profile of who you hire?
Yeah, we are hiring. We're looking for engineers at the moment. We're looking for folks who can help us with marketing side of things, with business development, and yeah. So we have Kayhan Space. We post our open positions both on our LinkedIn page and also on our website.
Marshall?
This kind of jumps into John Hunt's area, but how often do you track something and then lose track of it, and maybe get one of these surprise moves? I think they call them radar ghosts and so on like that, because eventually you have to talk to your customers about the accuracy and so on like that. And eventually somebody like John Hunt is going to say, how many space aliens have you found?
Well, that's a great question. The short answer is it happens all the time. And also that it is an active research area. So let me give you an example. Let's say, just hypothetical example, let's say there's a satellite and the operator downloads the GNSS data, does what's called orbit determination, and says, I think this is my trajectory, this is my uncertainty. Then US government uses their radars to track the satellite, and then they put out a solution and say, I think there's where the satellite going, and this is the uncertainty that I have. And then Stargaze does the same thing, and then commercial companies do the same thing. You put them side by side, they're most likely they're not the same, right? There's this little difference in them, but what is the truth, right? So the reality is that the more observation data you have, and you bring all those observations together, you get a better solution. So, for example, if you have all the observations from US government sensors, not solutions, observations, and then you have the commercial ones, and then the Stargaze and then the GNSS when you just throw them all together from a physics-based perspective and from physics perspective and mathematically, you get a better, you're more confident about the solution that you have. So again, it goes all of it goes back to data sharing. The more open we are, the more transparent we are as much as we can about the data and about our intentions in space, everybody will be safer. But obviously, you always have the national security missions that they just cannot be transparent about their intentions or their maneuvers. But generally, those are the operators that they're very capable, I would say, to keep themselves and everybody else safe.
So all space aliens are probably due to the military. I love that.
I think we're looking at some declassified information coming out soon, right?
Well, if you believe it, but
looking forward to reading those.
If you believe they're really going to give it to us, look what they did with Epstein files, which said they were going to declassify and release. And are they still releasing them? Are they redacted? Are they? Who the hell knows? So, if there's anything,
in many ways, space. I said space is hard, but politics and things that are happening on Earth are even harder. So we don't dare to solve those problems. We focus on the space.
But I suspect that space may be hard, but it's honest. I mean, space is not deceptive unless you don't know how to maybe run the numbers or something. But politics is based in large part on deception. So, what you see here covers up what's really going on over here, or however they do it. So that it's a fundamental difference. Have you found space to be tricky in the sense that it's deceptive or manipulative, or it may be tricky because it's complex and we don't understand all the different ways that you have to have data to deal with it? Is it manipulative or tricky in a sort of a nasty kind of?
No, I mean, I would say, not in a tongue-in-cheek way, but, we deal with math and physics. Math doesn't lie, data doesn't lie, data don't lie, physics don't lie. So, that's what we deal with. And both Araz and I, we are engineers by training. So engineers make the worst politicians, I tell you. So because we can't, we have to follow the process. So yeah, but and I think I mean, the reason that this work excites me every day to get up and work on these challenging problems is that I think the work that we are doing is very impactful. As Araz mentioned in the onset of the meeting, space is an infrastructure for the humanity, right? Like, basically every high-tech thing that you touch, not only that, your food production, agriculture today depends on space. And that is very fulfilling for us to have a small part in terms of making sure that we are growing this industry safely and sustainably, because we need space functioning as an infrastructure for many years to come.
Phil, did you have a question?
Yeah. I was wondering if you wanted to track a rocket launch and to get lots of data on it, is that possible? Is it publicly available information through which you could do that, or is that information all kept secret and it's really hard to get access to?
No, on commercial launches, actually, that is relatively public. So, you get the NOTAMs to close the airspace, and then you have the predicted trajectories that we have. One of our capabilities is that if you're launching a new mission, you can actually submit your predicted trajectory of first stage, second stage on the payloads and everything and we will actually run it against the catalog of a space object to make sure that it's not going to hit anything on the way up or down, right? So we have that capability. So for obviously for commercial launches, that's not really. I mean, it's not shared publicly, but it is shared, under the contract with contractors. But one of the nice things about space is that if you have the sensor, you can actually track things. Nobody can prevent you from doing that. So with a lot of these launches, what happens is that amateur trackers use different types of sensors to track satellites and then also launch vehicles sometimes. All of these, most of the launch vehicles are communicating on known frequencies. And that's very known. So if you have antennas, you can actually, and if you know rough trajectory, you can actually track them or listen to them. For example, the secret objects that U.S. government has, a lot of times if you're on Twitter, you will actually find tracking data for those that are produced by amateur just enthusiasts. But yeah, so to a certain degree, it is possible.
Guys, we're at the 90-minute mark almost. Does anyone have a final or concluding comment that you'd like to ask, or do you guys want to give a concluding comment about your work and your company?
I just want to thank you for bringing us on your program and allowing us to share our story and information. I think this is one of the first things we can do to raise awareness and spread the word about the challenges, the problem, and some of the solutions that are possible. Yeah, we are a fast-growing company. Again, we hire from different disciplines, and our mission is to make spaceflight safer for all operators. Today, we're focused on global space traffic coordination, trying to work with all the nations and all the operators to bring them together to have a platform where they can share their intentions and their maneuvers with each other to keep everybody safe. Siamak?
Great. Listen, thank you very much. I'll let you know when I get it posted on all of our different sources, and we'll follow it, and hopefully we can talk to you again down the road. And thank you for sharing all this information with us. Anybody have a final comment that they want to?
I was gonna, as the last comment for me, I was gonna say that we will definitely reach out to you, David, if we find any alien.
Yes.
You will be the first to know.
Well, maybe they already know and they just don't. So here's the thing. Why do you classify something if it's not real?
I guess that's beyond my pay grade.
But
to
so
answer.
so if he's
What
issuing
do you mean by real, David? What do you mean by
declassified,
real?
then there's something real to declassify.
What do you mean by real, David?
Well, if there's nothing to the UFO, UAP, alien visitation, all this stuff, if there's nothing to it over the last 60, 70, however many years since that flight over Seattle, then why is anything classified?
If
So,
it's our technology and we're trying to keep it secret, it might want to be classified, don't you think?
yes, and they won't release that no matter what.
I mean,
So,
Well, it might release
70,
something.
80-year-old technology is still classified? I don't think
Right,
so.
exactly.
yeah,
I agree.
well, it is nuclear technology
But
from,
it's not nuclear. It's a flying
but
vehicle
I'm
we're
just
talking
saying
about.
that old technology is still classified. Maybe it shouldn't be, but that's beyond my pay grade. But um,
I
uh,
don't think any aircraft are declassified. They're that old. I mean, the classified aircraft are more recent. I mean, right? Prototypes and stuff. Like whatever the
I don't
prototypes of these X-47s were before they announced it, that kind of thing.
Anyway, I'd be skeptical that our government would be totally above board, transparent, and honest, despite whatever president is issuing executive orders. So that's just me. My close to 80 years of life experience tell me something different about the conduct of government, and I guess I'd say I'll believe it if I see it. So. Guys, thank you very much. And everybody who joined us today, thank you very much too. And back for all of you on Sunday.
Thank
Goodbye.
you very much. Take care. Bye-bye.
Keep looking
Bye.
up. And thank you.